We have Brian Chambers here from Chick-fil-A. He is going to be speaking on how they use Kubernetes at scale across their network and organization, which is a massive network and massive scale. So it should be very exciting. I will let him introduce himself further. So I will hand over to Brian. Over to you. Thanks for joining us.
Awesome. Well, thank you for having me. Great to virtually meet everyone. Hopefully you'll have questions and we can get to know each other even better. So yeah, thanks again. I'll start by saying all of you guys are probably deeper experts on doing things with data in Kubernetes than I am. So I expect while sharing our story that I'll probably get some great questions or learn some things from you guys. But want to tell a little bit about what we've done at Chick-fil-A with Kubernetes in an interesting way. A number of you guys may have read different articles we've published about this. I tried to tailor this to be a little bit different, so I'll go fast over some stuff that's contextual. If you have questions about it, feel free to interrupt and ask along the way. But really want to tell you a little bit about our architecture that we do across our restaurants, specifically about 3,000 restaurants, and sort of how like data and persistence do and don't get implemented, and maybe some interesting trade-offs that we've made that are somewhat unique to us, but can be interesting when you think about architecture, and using Kubernetes in general. So my name, my role, just really quickly, is I am the chief architect or leader of the architecture practice at Chick-fil-A. So we've got a team of folks who do like foundational shared technologies across our different groups, our customers, our operators and team members, our corporate staff, and then some stuff in the business architecture domain as well. But we'll focus more on the tech side for the presentation today. So if you happen to not know Chick-fil-A, I can't see the chat anymore, but I saw a comment that someone was eating Chick-fil-A during this, so approved. That's awesome. But if you don't know us, we've got roughly 3,000 restaurants in the US and Canada. About 2,800 of those are run by us, meaning they're not like a licensee at an airport or something. And so about 2,800 of them would have this infrastructure that we're going to talk about today, but we'll just use the number 3,000 because it's easier. We're run by independent owner operators, about 250,000 team members. A lot of sales. We're really busy. We do more sales per footprint in 6 days a week than our competitors do in the full 7 days that they're usually open. And that matters not as a bragging point, but because it actually drives a lot of the challenges that we face at Chick-fil-A, where we feel like technology is something that can really help us effectively address them. So another stat to that end is that a lot of our restaurants are doing like way more volume than what the physical footprint was actually designed to handle initially. So we've found ways to keep growing, beyond just increasing prices or something like that, to grow with the volume and the demand that's coming from our customers. And that, of course, has also made us number 3 in terms of US restaurant chains behind McDonald's and Starbucks. So a little bit about us, just so you know, if you weren't familiar with Chick-fil-A, go visit a restaurant if we're in your area. We're not in New Zealand, sorry about that, but US and Canada at the moment, and Puerto Rico as well. All right, so I want to talk a bit about edge computing today, and edge computing really just, in short, putting the compute capability and the workload as close to the users as is necessary to create the experience that you want to be creating, but no closer. So we didn't do this because we think it's cool. We much prefer to build everything that we can build in the cloud because there's just way fewer constraints, and there's all kinds of amazing managed services and different kinds of things that exist there that don't natively exist like in the back of a restaurant. But there were things because of capacity challenges and places we wanted to apply technology to help our operator and team members in the restaurants, and then to create better customer experiences that justified thinking about a footprint that could work, systems and apps that could work even if the internet connection was down, which it happens. Things that could operate with really low latency where needed. Think about things in an order pipeline or in producing food or things like that. So that's kind of the why really quickly. And again, happy to field more questions about it. But we've written about it a bit, and I've done a number of other talks about it, so I don't want to drag people through it again if they've already heard the same story. So I wanted to tell you a little bit about how the architecture of these nodes works, just so you can kind of get an understanding. So that's the next couple slides. So essentially what we did is we put some Intel NUCs, 3 of them per restaurant. And this is a picture I took a couple of years ago, but it's still the same thing that we have. And just to give you a comparison in size, like they're about the size of a Chick-fil-A sandwich in terms of like their total height. So they're pretty small. We're really space constrained in restaurants. So like we don't have like a server closet. We don't have like racks. We don't have all the fancy stuff that you would see in a lot of businesses, even maybe like other retail, like a Target or Walmart or something. We're dealing with like small spaces in offices and things like that. So we had to go with a small form factor. And essentially what happens with these is, this is oversimplified, but we essentially have these 3 NUCs. Each of them looks identical and is identical across every store in the chain when they show up. And they basically have this stack to the right. It's the NUC. There's a disk partition scheme, which there's some cool stuff there that helps us do things like zero-touch provisioning and remotely wiping and resetting these back to their initial state that we do. That's kind of like a mirror of the way Cloud.init works, if you're familiar with that. Then we've got the OS, which is Ubuntu. K3 is ultimately on top of that. No virtualization, no hypervisor, none of those things. It's basically K3 is on bare metal with some little like homegrown things that we did to make management easier. And then the applications live on top of that. So to give you another picture, kind of what the architecture looks like, we've essentially got this edge K3s, and I'll talk about that in a second. And then a series of services. So think about the apps that live there. We've got essentially a bunch of platform applications that exist that assist the developers who want to build things for this in-restaurant platform. Those are things like local authentication services. We do a ton of MQTT, which I think we'll talk more about in a minute, deployment, storage, et cetera. And then we've got applications that other teams can build. And I'll show you kind of what that looks like in a moment. It's also just good to be aware that what drove us to do this in the first place. I mentioned capacity and the challenge of growing restaurants beyond where they were. One of the things that we recognized as a business was one way to scale and do better, continue to maintain great customer service and quality while doing more volume, was to put more technology in place. And so a lot of what we started with was actually trying to get like more real-time visibility to what was happening in the restaurant, to get a better understanding of what was going on in the kitchen specifically, is where we started, because that was one of our biggest capacity challenges, in addition to probably drive-through. But kitchen's a big deal. So we started off doing this with really a bunch of kind of smart kitchen is what we would call it, use cases. And the very first things to come along were a lot of the fryers, grills, holding cabinets, and then like applications that were custom, that were built consuming a lot of that data, and then creating things that made the team members' jobs simpler. Like we have an article out about a thing that we call automated holding assistant, which is a solution that basically looks at chicken pans as you check it in. It's got barcodes etched on it. There's a camera that captures that and essentially tracks that pan through its life cycle. To make sure that like when it gets to the end of a timer, it gets discarded. It's a food quality issue for us. So things like that are really hard for people to remember to do at scale and kind of cumbersome. They're manual. Trying to put automation to make systems that are easier for our team members to use, pretty low touch, but that make sure that we're doing the things that are really important to our business really well. So that's just one example of the type of application that might live on top of this stack that's in the restaurants. And then, of course, we've got like a big cloud control plane that lives in AWS in our case, that does a bunch of the stuff to coordinate deployments across those, consolidate data that comes out, provide observability, the more centralized authentication authorization stack, all those kinds of things. So this just kind of underscores what I mentioned. You've got this stack, the red stuff being the things that exist under the control of the platform team, the one that's rolling out and managing all the NUCs and the Kubernetes and K3s and all those kinds of things. And then we're essentially, think of it like akin to a cloud provider. We've got other teams that leverage the platform itself to deploy container-based applications to the edge, and then also use those kind of like, not really primitives, I guess, but like those medium level services like MQTT for messaging, so they don't have to roll their own, RabbitMQ or Kafka or something like that. So they don't have to build their own deployment services. We've got that covered. They don't need to worry about auth, and they don't need to worry about database either, which is what we'll spend time talking about in just a second. So we give teams a lot of autonomy. They can sort of like pick and choose monitoring and observability tools, programming languages, things like that. But we are opinionated about the things in red, which is you have to use this platform, you have to be container based on top of K3s, and you have to use some of these certain services and not roll your own just because it's a constrained environment. That's essentially the way it works organizationally. Before I go to data, I'll just mention maybe a really fast, like why Kubernetes. This is a Kubernetes related group. So this all started, we've been running this for almost 5.5 years. So we were pretty early-ish in the Kubernetes lifecycle. And what we knew when we started doing this was we wanted intelligence in the restaurant to be centralized somewhere. Like we didn't want to have like sales transactions from point of sale being sent into fryers, which were trying to like run applications on fryer to like decide something about what they should do. And people were talking about that with trying to automate cooking fries, for example. We knew that that was not going to be a good, scalable, supportable architecture. And so we knew that there needed to be a place where we could have people build an application that could do things, consume data in restaurant, telemetry from kitchen equipment, events that team members are doing, downloading things from the cloud, like sales forecasts that we compute, like in aggregate across the chain, making adjustments to it, things like that. So we knew we wanted to be able to do those kinds of things, and that needed to live somewhere. So that led us to this whole edge footprint in the first place. That's kind of the why behind actually having edge compute. And then if we were going to run containers, we looked at all the options, Docker Swarm and HashiCorp, Nomad, and some other things that were around at the time. We actually, our initial glance at Kubernetes, we were like, it seems too big and heavy, for our footprint, for a restaurant, et cetera. But right around that time, I think this is 2017, maybe, the KubeCon in Austin, it just got really clear, like Kubernetes is where the industry is going. It's where the open source community is going to be. It's where the momentum is going to be. And we didn't really want to be off on some thing that left us like writing all of our own stuff from scratch forever. A great example might be like Vector, which we use here. Like it's awesome that we can just plug Vector in to Kubernetes and get a lot of logging and metrics pipelining, based on some awesome work that the community has done. So we wanted that, and then there was K3s that came along, which for those who don't know, is Kubernetes, but it strips out a lot of the cloud related components. It was initially just supported SQLite instead of etcd, and then it's single binary, so just a little bit simpler from a stand it up, get it running perspective. It's mostly built by Darren Shepard over at Rancher at the time, Acorn now. So all that together kind of got us comfortable with Kubernetes as a construct, and we kind of rolled with it, and it's been great. Haven't really looked back or regretted that decision at all. But we did take a really simple approach to using it, which was we tried to not get really cute about everything that we could possibly do with Kubernetes, which is a lot, and it's really easy to see your scope creep into a lot of things. We tried to keep it to the simple and basic stuff as much as possible, which is we want to be able to run applications across multiple nodes and have them get scheduled such that if the node they're running on dies, the cluster brings them back somewhere else. And then we do a couple other really very basic things with Kubernetes, but we try and just keep it as simple as possible because we're talking about a 3,000 cluster footprint, which if you get cute, I think gets really difficult to manage. So if there's questions about that, let me know. All right, so let's talk a little bit about what types of data exist. So I kind of alluded to some of this.
Brian?
Yeah, we have a question.
Brian, just quickly. Yeah, I realized I forgot earlier that people attending can't unmute themselves, but there's a couple of questions from the chat.
Oh, yeah, sure.
If I could, before you move on to the next section, if I could drop those in. One was from Noel asking, so do you use Ubuntu 18? So what's involved in upgrading at Chick-fil-A scale?
Yeah, great question. So I mentioned we picked 1804 because it was the long-term support edition at the time. There were like some things that were great about that decision. There's also some extra junk that made its way in by then that was a little bit of a pain to deal with. We won't go into all of it at the moment, but happy to have a sidebar afterwards if interested. But upgrading is a great question. So generally speaking, there's obviously patching that comes along, and that's fairly straightforward to apply to stores. like a full OS upgrade, we actually haven't had to do, but we've done similar things like K3s and things like that. So full OS upgrade, the way that we laid this out, I'll go back to the slide real quick. Just this one's probably the best. So that partition scheme that I described, we basically, we slice up the disk that's available on each of these nodes into a couple different partitions. One is the one that actually has like we have a caching one that persists through any sort of like wiping, or sort of wiping the cluster. We can basically take these nodes remotely and have them reset themselves to the initial way that they showed up, which is like the NUC, the base image that we have on it on one of the partitions, and in that partition scheme. So essentially, we're able to do some stuff with like flipping between partitions, and then dynamically providing a sort of like an init script to the node each time it starts up. So we do some things with overlay FS. So everything like all the K3 stuff, all the security patching, anything that gets layered on to that base partition that you start with is on an overlay FS partition. And we're able to do some little tricks with it where we can effectively confuse it based on the absence of the key, encryption key that it's looking for, to make it think, oh, I need to reinitialize this. So we have some little tricks that we do from the cloud side where we can like toggle on and off and say, hey, reset yourself to the initial state. And then when it checks back in, it picks up some instructions essentially that tell it what to do, like how to initialize itself, whether to form a cluster, join a cluster, et cetera. So we can change those instructions per node, per restaurant dynamically whenever we want. We obviously don't like get to a point where we have a bunch of unique ones across restaurants, but there might be like 2 different versions of it at certain times when we're doing some sort of like rolling upgrade or something like that. So that's the long answer. The short answer is some intentional partition layouts, some overlay FS magic, and then kind of like a cloud init type equivalent, way to tell it what its instructions are when it boots up the first time.
Cool. There was one other question from Roberto Miller. He asked, do you use an operator within K3s to manage the Postgres instances?
No, and we'll kind of come to like our super simple Postgres implementation in just a minute. So stand by on that one. But no, we don't. The only, off the top of my head, the only operator I can think of that we have one that we built that when secrets get changed, we'll do pod restarts based off secret change, but that's pretty much it. We've tried to stay super simplistic. I'm sure I'm missing something, but in terms of like custom operators, we haven't done a lot. Okay, awesome. So just to give you a flavor of what kind of data is involved here. So we talked about like kind of kitchen equipment, telemetry. So just to make it a little bit more tangible, like for a fryer, for example, anytime it starts a cooking cycle or finishes cooking, starts a cleaning cycle, finishes cleaning, and then as well as just like heartbeat events that come out all the time, like of all the different heating element temperatures, oil temperature, all these kinds of things. And you may be thinking like, well, what do you need that for? Some of that is really useful for understanding like equipment performance and health, for trying to look for potential maintenance issues, quality issues. If like the heat, the temperatures are too high or too low, that's going to impact, cooking time, which could be a food safety issue. If it's like on the low side, it could impact quality if it's, something's running too hot. So those are useful kind of telemetry items to gather from our kitchen equipment. Most of our, to be honest, most of our IoT data today is kitchen oriented, but it comes across like fryers, grills, the holding cabinets, some refrigeration devices. There's, I think, about 15 to 18 different discrete kitchen equipment components that are connected and sending out data through the system. So that's the majority of the kind of IoT stuff. The next class I would say is like app generated data, meaning like an app that's running on the edge. So it could be like, we would consider the AHA, automated holding assistant solution. There's another one for fries called Fraha. But we would consider that to be like an app that runs in restaurant at the edge. It's got sort of the intelligence externalized to the edge compute nodes, and it's generating data about what's happening in that system, as well as consuming things, over MQTT within the restaurant as well. So that'd be kind of another bucket of data, is things that those apps are creating, or perhaps even like downloading from the cloud, like a forecast or something like that. We've got POS. POS is kind of like in flux for us. So we initially, for most of the time the solutions existed, we've been on a proprietary or commercial off the shelf with changes made by us point of sale system. And so we did some things to basically get finalized transactions, like poked a hole from the POS world over to this edge ecosystem. But we're actually actively redoing our entire point of sale infrastructure. And that's going to open up over the coming months and years chain wide, but over the coming months, everything from our POS ecosystem, which was really closed historically, to be able to flow through here, which means lots of other things you can do from an application perspective. So keystrokes, meaning like every time somebody hits something on a register, which would represent like, imminent demand for that item. Somebody wants it right now. They're ordering it right now, which can be helpful to not drive exactly what we're going to cook, but, adjust forecasts or things like that. Finalize transactions, speed of service metrics, different things like that. So there's a lot of stuff in the POS ecosystem that's really important that'll be unlocked. It's starting to now. We have it in some stores, but it's not to chain-wide scale yet. Another class would be like all the system telemetry. So the stuff to operate and manage both the platform. So all the things in the red boxes on the slide we looked at a minute ago. And then of course, we have customers of our platform building applications, and we need to provide them, metrics and logs and observability data about the solution as well. So I just did a talk about that at Datadog Dash a week and a half ago. So that should probably be online if anybody's interested in the kind of the observability story. We won't go into that one much more from here. And then finally, I consider this to be incoming because we only have a few footprints of it at the moment. But one of the things that we want is to do kind of what we've been able to do in the kitchen in other parts of the restaurant. So we've got a number of solutions we're evaluating at the moment at small scale, like less than 100 stores, but operational telemetry data, meaning like business operations. So like seeing for each car that comes into the lot and into the drive-through, like what's the total time it takes us to serve them. So knowing they're on the property, this is the point at which they were first had their order taken, which isn't always a fixed point for us. We have people out with tablets in the drive-through taking orders, so that could be dynamic. So being able to know when did they get their order taken, and how long was it before they got to the window, and then how long before they could actually exit the property, that would actually represent like the full, drive-through customer experience. Whereas today, all we know is from the time somebody hits a button, bringing their order in for the first time, she may have been on property for a minute, 2 minutes, 5 minutes at that point. Like we don't know until they actually, make it all the way out and leave. So, so things like that. Same idea in indoors with tables, like knowing occupancy of tables so that we could maybe trigger to know when to go clean them or things like that. And, timing queue in front of the registers and on and on and on, right? So we're looking at some CV and LiDAR related solutions, CV driving more compute and GPU capacity in stores than we would ideally like to have to deploy and figure out how to manage at scale like we have with this other stack. And LiDAR being a little bit more lightweight and also, non-invasive. You can't tell who a person is, so there's no privacy concerns there. So we kind of like that. But those are some of the data elements that are inbound and that we're working on actively. Oh, on the chat. Okay, cool. So talk a little bit about persistence, which we've made a lot of like simplifications in terms of how we think about this. So we just talked about the data flowing through the restaurant and kind of playing off, data is the new oil. Essentially, I would say you could simplify this whole architecture for in the stores to say like, this is a way to enable data flow through the restaurant in a non-siloed manner that multiple people can tap into and consume when they need it. And that's really the way I would think of it. So it's not a repository for long-term storage. It's not an oil refinery where we're doing all of the fine tuning and perfect, data cleanup or anything like that. It's really a means to ship things from in restaurant ultimately out to the cloud, which we still try and do whenever we can, based on connections being up and things like that. But essentially it's that, and it's being able to tap into it if you have something that you need to do in the store, which is maybe breaks the metaphor a little bit. But I just imagine somebody coming in and siphoning off what they need, for their use case and building off to the side a little bit, in this picture. So that's the way I would think about this architecture. And that leads us to our persistence strategy, which I think you guys will find interesting. So 3 big things here, and I'm sure there'll be questions, so feel free to drop them in the chat. Number 1, persistence at the edge is best effort. So we do not do any service level agreements. We make no guarantees that it's always going to be there. If you use one of the databases that we have available, which is primarily the Postgres one, if you use that Postgres database, like we're going to do best effort to keep it up within Kubernetes. But we made a trade-off to say, we think given the number of footprints and the potential issues that could happen with making a really highly available database that people come to trust, and where it breaks things significantly when it's not there, we're going to end up in a lot of trouble. And so we went with this approach of persistence is best effort. It's not, it's not highly available. We would even probably say it's more of a recoverable architecture than an available architecture, as is our entire edge stack. So one of our management techniques for Kubernetes cluster problems or misbehaving items, as well as like patching and upgrading, is, as I mentioned, wiping a node back to its initial state and reinitializing it and having it rejoin the cluster, either like at the whole restaurant level if something is terribly wrong, so we could blow everything away and bring it back, or more likely it's at a node level and it's able to be blown away, come back and rejoin the cluster. But that's a trade-off that we made, and it has served us well, actually. And there's the next point will explain that, or 2 points away will explain kind of how we mitigate that as well. So we have a local database for convenience purposes. We actually have 2 local databases, which you'll see in the picture in a moment. But Postgres is the one that any of our teams would use for whatever they need. We would say treat it as a tool. So a place to drop stuff temporarily, to maybe do some, like, if you've got something that SQL is really handy for, if you want some degree of persistence outside of an app restart or something like that, it can be useful for that, but it's not intended, again, to be like the long-term repository for the application's data or like the business's data as a whole. It's kind of a tool in the toolbox that you can use, with your app. And then what that means is that we actually encourage, and this is the reason for the iPhone picture, I think it's the most tangible way to talk about it. So when you get a new iPhone, you like turn it on, you connect your iCloud account, and everything like magically rehydrates, right? Like your photos come back and your apps that you had downloaded come back, et cetera, et cetera. That's essentially what we have encouraged development teams to do with their applications at the edge as well. So you may not always be online. So sometimes you may have state that hasn't been sent out to the cloud, and that's okay. And in most cases, there's enough resiliency in the architecture that you're gonna be fine. Like you're gonna get a connection back. It could even be a day later. It's very unlikely that you have a situation where you lose all of the nodes in the cluster and the internet connection was down. It's probably more of a disaster, like a lightning strike or something, if that happens anyway. So we don't really see a lot of those cases. But even if we did, most of the data that we're dealing with that's in this ecosystem is important for making like near-term automated decisions, not for like long-term like financial reporting or something like that. So generally speaking, we're encouraging apps to send data out. So flow through, consume, use in restaurant, all great. When you have a chance, like hydrate the state that you care about out to the cloud. And then if your app goes away, one of the things it should do when it starts up is see, is everything I need here? And if not, let's suck things back down from the cloud and reinitialize. And that pattern has both been fairly straightforward for teams to work with in the restaurant edge, and it has made managing a Kubernetes environment like this at the number of instances that we have much more manageable. Like there's a lot more support vectors that we can take that we couldn't take if we had to never lose anything at any store ever. Like I don't think we would have succeeded if we did that with the team that we had, the size that we had, and the use cases that we've had. So I think it was a good trade-off, but definitely a trade-off for sure, and not one that probably everybody can make. So here's a little picture of what that data flow in the store looks like. So the bottom would represent the edge. So we've got MongoDB, which it actually is really only used to back It's actually 80s, which is a MQTT broker that's from Mosca JS, and 80s doesn't have a logo. So Mosca it is, but that's our MQTT broker, which is really our primary data hub for the restaurant. So not a lot of like REST API interaction inside the store or anything that you might typically see in like a microservices architecture in the cloud. It's more message oriented. And so most of our applications that we were talking about are really pub subbing, MQTT, and then most of the REST stuff that they would do would probably be interacting with like services that are deployed in the cloud outside of the restaurant. So that would generally be to pull things down, like a forecast or something like that, or to publish things out that are specifically related to their app up to like kind of their control plane for the app across the whole restaurant footprint. So that's pretty typical. Mongo is basically there to back that. We don't make Mongo available since we have Postgres. We don't make it available to application teams. Again, should be simple use cases. That's what the Postgres one is there for. And Postgres we just talked about. So that's what we have there. We hit Mosca. And then in very rare occasions, we've had reasons for people to write things to like a local file system. And we've been playing with, we aren't at full scale across the entire chain, but some of the stores have Longhorn running across from a persistence perspective. We had a couple little issues with it. I'm not expert enough to tell you exactly what they were, but we had a couple issues with it, so we haven't fully rolled it out yet. But a bunch of stores have Longhorn doing replication of file system, so distributed file system effectively for a persistence store as well. So kind of S3-ish, but certainly not as as resilient as it would be. So that's essentially a bit of the storage service and persistence story as it relates to the restaurant edge. So almost at the end of my slides, but some design principles that maybe I can just summarize here that we've kind of talked about implicitly throughout. So highly recoverable architecture over highly available. Like generally speaking, the way we do Kubernetes, the way we do databases, the way we tell people to build their apps are more about being able to recover and get back to a state that makes sense than they are like, let's make this the most highly available architecture that's ever existed. HA is awesome in the cloud and very reasonable with multiple availability zones and regions and distributed database services and all these things that that you can leverage. But that is very, very difficult to replicate in a quick service restaurant, even one, let alone like 3,000. So we made that decision to go that route, and that really applies to most of what we do. I mentioned this before, but we try and keep our K3s usage to the bare minimum. So as little cuteness, as I like to put it, as possible, and make trade-offs and accept that this is a constrained environment, so we have to allow those constraints to sometimes get us to engineer for things that are important. Like I would say our partition scheming and our overlay FS stuff and our ability to like wipe a device back to its initial state was a lot of engineering work that was around some of the constraints that existed in our environment, like not having IPMI or Pixie Boot or things like that would have been really awesome. So we really had to engineer around some of those constraints because being able to support this at scale was really important. But other constraints, we had to say that we'll accept that and we won't offer maybe the same service levels or the same guarantees that we would do if this same architecture lived only in the cloud, for example. And that really, again, came back to ability to operate at scale, which, if we can't do that, it doesn't really matter how awesome all the other decisions were. We've got to be able to operate it at scale. So another trade-off there, but we've been happy with that one. And then, like I said, we have no persistence SLAs, but it's best effort. It usually is there. That's great, but app teams can't depend on everything always being up and things that they wrote always being available. So it encourages a little bit different application design philosophy. That's been a journey as people learn to operate within it, but certainly none of these three are things that we have regrets over. It's been empowering and it's been good trade-offs to make the architecture supportable. And that's all I have in terms of slides. So I think questions would be the next thing if we still have time. But if you're interested in something that you think is tangential to this and you want to learn more, you can find me in a bunch of these places, LinkedIn. I do a Substack thing, and then Chick-fil-A specific stories. You can find a lot of these like a lot more about the context behind the edge architecture, that AHA article that I mentioned, which is really interesting, like what one of the teams on top of the platform did. They were actually our first customer and more. That's all on the Chick-fil-A tech blog. That observability story is actually there as well. So you can check that out. And I think that's it. Are there other questions? I don't see any in the chat, but other questions I can answer?
Awesome. One question just came in right now. I can read it out so people get to see on the recording, but how do you deal with the connectivity between the edge and the cloud? Do you use some VPN or some other tools such as Scupper or something similar, or simply encryption or authentication over open internet?
Yeah, the latter. So simply encryption and authentication over open internet. So we do secret store, like a managed secret store, which is HashiCorp Vault runs in the edge environment. And we do synchronization of secrets as part of the part of our whole like edge bootstrap process. So they have secrets there that they can get to access protected services. But then there's also, so I'll try to do this without going too long. Essentially, we have we call it GoAuth. It's a custom homegrown OAuth compliant server. If you're asking why would Chick-fil-A do that, why not just buy it? There are a couple things that we will cost for one in terms of the number of clients that we have, and then two, we wanted some of the flows that were not yet available in a lot of the commercial products, like OAuth device code flow, which is like what you'd see with like you want to log into ESPN on your Apple TV or different things like that. And you get that kind of asynchronous flow of enter a code, et cetera. We did that for some of our devices early so that they didn't have to like do anything on the actual device to log in. So externalize some of that. So anyway, we have an auth server that lives on the cloud side, and then we have a local one. So the cloud one's job is basically onboard anything that needs permission. So that could be the Intel NUCs themselves end up with identities for various reasons. Any IoT device, Fryer Grill, et cetera, those all onboard through OAuth as well. And then any of the applications that exist in this edge footprint also get their own identity. So we basically are minting a JOT, a JWT with the permissions embedded in there. So it'll be full permissions for services that can be accessed, both MQTT topics, pub and sub at the edge. And so we enforce those in our broker, and also for cloud resources as well. So things that they might want to access on the cloud side. And the reason we put the full permissions in there is for this offline resilience thing. So if you can't reach the cloud broker, but you need to keep operating in restaurant, the local auth service actually acts as a proxy first, and it just is a pass through if the cloud auth server is available. But if it's unavailable, that can actually re-sign with a different, re-sign the same permissions with a different OAuth provider in store and maintain continuity from an authentication perspective. So that's how that works. But yes, we ultimately just use that facility to talk to protected resources on the cloud side, and we don't do any sort of VPNs or anything. All traffic is outbound from the edge to the cloud. We never, ever have any case where there's a inbound web request or message or anything else. It's all like, it could be over the MQTT rails, but that's a connection open from the store out to the cloud. So that's the way that ultimately works.
Thanks, everyone. And thank you so much, Brian. It's great to have you.
Appreciate it.
Cool.